We looked at just in the past episode, in the last episode, we looked at a function as a vending machine. We had a whole board over here and we were talking about vending machines, all right? Maybe you didn't understand all of it, but you understand a little bit, okay? Now we're gonna get into functions as real life examples, okay? Forget about the vending machine for now. Let's understand what a function is. A function depends on something. Something depends on something, okay? I'll give an example. Your battery in your phone, whatever your percentage is on your battery or in your laptop or wherever you're watching this from, it's a function of time. Why? Because if your battery drops to 0%, you're gonna plug in the charger and it's gonna take some time until it gets to 100% again. And if you're at 100%, it's gonna take some time of using the phone, maybe playing Call of Duty or something, until it hits 0%. So the percentage of your battery is a function of time. What's another function of time? Okay? A kettle. Yeah, when you boil water in a kettle, that is a function of time. That's an example of a function of time. When you put cold water into a kettle and you hit the power button, you don't get hot boiling water 1 second later. You wait a couple of minutes. Maybe you wait 10 minutes, 7 minutes, 5 minutes. It depends on your kettle, okay? Who manufactured it. But the point is it takes some time. You don't just get boiling water 2 seconds later. It takes some time. When you take the same boiling water and you put it out on the table, it's gonna take some time for the boiling water to cool down. That's an example of function of time. What's another function of time? Your height, how tall you are. That's a function of time. When you get born, you're like this tall. This tall. How tall are you? Like this tall? And then as you grow, as you age, you get taller. Now, yes, obviously, at some point, you reach a constant, a point where you no longer grow taller. But forget about that. Forget about that point. We're just talking about like your first 20 years on the planet. You get taller. Here's another function. The length of a pencil. You know a pencil? The thing you write with? The length of a pencil depends on how many times I sharpen it and for how long I sharpen it. I'm pretty sure you've had a pencil in your life. Have you ever sharpened a pencil? If I do it once, like this, the length is not gonna change that much. Yes, it changed a bit, just a little bit, but not that much, all right? But if I keep doing this for over 2 hours, the pencil is gonna be this long. So it's a function of how many times I sharpen it and for how long I sharpen it. So if I sharpen that pencil 1,000 times, but one sharpen, one turn lasts about 0.5 seconds, the length is gonna take a couple of time, all right, to get short. But I can sharpen a pencil just once for 3 hours. It's gonna get very, very short, very, very quickly. So the length of a pencil depends if I sharpen it or not. And if I do sharpen it, it depends on how long I sharpen it. Okay, that's another example of a function. Here's yet another example of a function. I'm gonna keep giving you a couple of functions I can think of so that you really get them. Your allowance, say your parents give you 2% of their salary every month. Your allowance is a function of their salary. Depends on their salary. Because if they get a high salary, if they earn more, you make more. If they earn less, you make less. Because you get 2% of everything. You understand? So if they earn 0, if they get fired, you get 0. But if they win the lottery, you also win the lottery because you get 2% of that money. So your allowance depends on their salary. Hopefully they don't get fired. Now, here's another function you're probably going to relate to. The muscles. At the gym, when you go to the gym to gain some muscles, there's a couple of things that your muscles depend on. Number 1, you need to go to the gym consistently. Number 2, you need to drink enough water. Number 3, you need to get enough sleep. Number 4, your diet needs to be on point. Number 5, intensity. Number 6, intensity on the exercise type. If you're going to do squats, but you want to grow your muscles, man, come on now. You see? So there's like 6 things your muscles depend on. But there's one output, your muscles growing. See, it's multiple inputs, one output. Your muscles to grow depends on sleep, diet, exercise type, exercise intensity, consistency. It depends on a lot. Protein, but with one output, your muscles growing. That's an example of a function. Okay, it's still multiple inputs, one output. Just like in lesson 1, it can have multiple inputs, but one output. One input, one output. An ice cube, not that ice cube. I'm talking about these ice cubes, okay? An ice cube is a function of time. When you put water into an ice tray and you put it into your refrigerator, it's not going to be ice cubes 1 second later. It's going to take some time. You put the water in there, take some time for them to become ice cubes. It also depends on the temperature of the water when you put it into the refrigerator. If you put boiling water in here, then you put it into the refrigerator, it's going to take way longer than if you just put tap water. The ice cubes, not the wrapper, these ones, it's a function of time. It also depends on the material of the ice tray. But the point is, something depends on something. Just like X and Y in the coordinate plane, Y depends on X. Yeah, I got it. Another function of time is hot water. When you open the faucet or tap in your house, the moment you open it, the hot water comes out. It doesn't happen. You can go try it out in your kitchen if you want. Now, of course, it depends on your plumbing in the house, but I promise you, there's gonna be a delay. Go to the tap right now and turn on the hot tap, the hot faucet, turn it. A little bit of cold water is gonna come out first and then the hot water. It's an example of a function of time because it takes a certain amount of time before you get a hot water. This is a container with hot water. That's why I drew it in red. The water in the pipe is cold water. That's you in there. You taking I don't know, man. What color is water? It's blue. All right. You're taking a shower in there. Let me draw some blue water. You're taking a shower in there. All right. You open the tap. First, what's gonna happen is all of this cold water in here is gonna flow to you first. And after all this cold water in here has flown out the faucet or the tap, then only the hot water will come to you. So what am I saying? The temperature of the water while you're taking a shower is a function of time. Let's say it's going to take you 10 seconds. 10 seconds for all of this cold water to come out and eventually for all of the the hot water to get to you. So what does it mean? You know, in the first 10 seconds, you need to let that shower run without you inside. So all the cold water can go out. And then on the 11th second, all right, let's just keep it in integers. On the 11th second, now you can jump in there because all the hot water is going out. Now, what happens if all of this hot water finishes? The tub, the container, it's finished. There's no more hot water. You're telling me you're not going to have water? No, impossible. Okay, you need to have water. That means there has to be a second container over here somewhere, and it has cold water. So when this tub finishes with hot water, you are going to have this one funnel its water to you, and the temperature of this water is going to be cold. It's going to be cold. So first we started off with cold water, and then we started to increase into hot water. We stayed constant. Let me draw it for you. So let me draw the graph for you so you see it, okay? You're gonna see the graph I'm talking about. I'll just draw it in the middle here so you see it. I don't wanna erase the whole picture. So it's not accurate, it's just a rough sketch, okay? So it was something like this. First, I'm gonna use the blue so you understand. It started something like this. The temperature started increasing. This was still the blue, okay? And somewhere here, it started to get red. And then it stayed constant because the temperature in there is the same. Yeah, it may drop a little, it fluctuates here and there because as it's going through the pipes, it's gonna cool down a little bit. But then, after the water in here is finished, what happens? Temperature then drops again. Because now it's this container funneling the water to you. So what is it saying? It's basically saying that the temperature in the shower of the water, it's a function of time, depends on time. I hope you got what I was trying to explain there, okay? Hopefully you got it. Now, here's another function. Your experience of a horror movie depends on a couple of things. Now, you've watched a horror movie, right? Maybe you've watched It, or maybe you watched Pennywise. No, Pennywise is It, sorry. Maybe you've watched Chucky. I like Chucky, the doll, all right? Maybe you're watching some horror movie. Your experience of the horror movie depends on a couple of things. Number one, if you're watching a movie at midnight, it's gonna be spooky. But if you're watching the same movie at 9 a.m. in the morning, it's not gonna be as spooky. So it depends on the time. Your experience of the horror movie, the quality of your experience, it depends on time. What time you watch it. Is it at night? Is it during the day? Now, your experience of a horror movie, again, depends on something else. It depends on your company. Who are you with? If you're with your friends and you're watching a horror movie, it's not gonna be that scary. Because someone is gonna pop a joke, or someone is gonna get scared and we all get laughing at that friend. Aha, you got scared. You know, someone's gonna be farting. You know, it's not gonna be that scary because your friends are around. But if you're alone, it's gonna be scary. Alone at midnight, watching Pennywise, not gonna be very friendly. Now, here's another factor. It also depends on your environment. Your experience of a horror movie also depends on your environment. If you're watching that same movie in the schoolyard and there's kids playing around, you can see the kids, it's not going to be nice. But if you're watching it in a dark basement and the doors are creaking, it's going to be very spooky. Do you get it? So now that's a good example. That's a good example of a function having multiple inputs but still one output. Okay, having multiple inputs. The first input is your environment. Second input is the time of day. Your third input is, what did I say? The third input is the company you have, the company you keep. I like that series. It's called The Company You Keep. Unfortunately, there's no season 2. But anyway, your experience of a horror movie depends on a couple of things. Okay, now let's stop with the intuitive functions, okay? I've given enough of them. Let's get into the mathematics. Here is a mathematical function that you'll probably understand. You know about this one, okay? Pretty easy stuff, okay? The area of a circle. That's the area of the area of a circle, okay? Now, I'm going to give you an animation on the screen in a minute, but it's based on this. Area depends on the radius. As the radius of the circle gets bigger and bigger, the area of the circle gets bigger and bigger. The area of the circle depends on the radius. You need to understand what this means. This f of x or f at x. You need to understand what this means. This thing here is very important. Okay, this is called function notation. Okay, now in the definition of a function, it says a function f is a rule. What does that mean? X, that's x. Say, now the x can stand for anything. X can stand for 10, 12, 1, 2, whatever. And then I say, add 2 to that number. This is my rule. I said, whatever number you can think of, add 2 to it. So if you think of 7, the answer is going to be 9. If you think of 10, it's going to be 12. If you think of 90, 92. That's my rule. So if a function f is a rule, that's what the definition is saying. Now, why did you choose f? You can choose anything, man. You can say g, a function g is a rule. You can say a function p is a rule. Okay? Now, the simplest way to explain this is if I explain it this way. Okay? Now, we'll come back to this. Why do we use the f? When do we use the g? When do we use the p? Let me explain. Okay, now that is not drawn accurately, okay? But the point is, we have 3 graphs here, okay? Now, I could say, this graph over the blue one, the straight line, is y is equal to, let's say, x, 2x. Now, this is not correct, okay? This is not accurate. 2x plus 1. This is not accurate. This equation is not the graph, is not the equation for this graph. I'm just giving an example, okay? We say the equation to this line here, the straight line, is y is equal to 2x plus 1. And then we say, for this parabola, it's y is equal to x squared. Because that's the equation of a parabola in my particular case, okay? And then for the green one, which is a cubic function, we say the equation for this cubic is y is equal to x cubed. Now, this is not wrong. Green matches green, red matches red, blue matches blue. But this is not very convenient. Why? Because you're not going to always have color around you. What if you just have a black pen? You know? So think about it. Now think about it. If I had to cover this, don't look at this, cover this whole thing. If I said the graph y, which graph are you talking about, Sia? Because this is also called y. Y is equal to. Y is equal to. Y is equal to. So which y am I talking about? Which graph am I talking about? See? So we need to specify them. That's the easiest way to understand this. We need to specify them. So instead of just calling them y, we're going to use function. Let me draw this properly. I'm going to raise the whole thing so I can draw it properly. All right. And so instead of just calling them y is equal to, let's specify. Let's call this blue one. Let's use function notation, which I'm going to explain in a couple minutes. Let's call it f of x is equal to that equation I had here, 2x plus 1. For this red one, the parabola, let's not call it y is equal to. Let's call it g. G of x is equal to x squared. And for this cubic, let's not call it y is equal to. Let's call it t. T of x is equal to. Now, when I speak about t of x, you know I'm talking about the cubic. When I say g of x, you know, now let's say, now I have to erase this and draw it again, okay? I'm going to erase it and I'm trying to show you the point of this. Now wait. See? Now I took out the color. So you don't know which one it is based on the color, but you can still tell me which one it is because I used function notation. How does it make sense? Because that x squared, I know it's a quadratic, it's this one. This x cubed, I know it's a cubic, it's this one. I know I didn't draw this properly, but it's a cubic, it's this one. The one that looks like an S. And obviously the straight line is that one. So when you say f of x, I know which one you're talking about. It's a straight line. When you say g of x, I know it's the quadratic. When you say t of x, I know it's the cubic. So you name them specifically. And if I wanted to add another one, let's say I wanted to add what? Let's say an exponential. I wanted to add an exponential. I can just call it p of x is equal to what? To the power x. Now, obviously, these equations are not correct. Okay, they're not correct. But I'm just giving you an example. Okay, this is why we use function notation to specify. That's the simplest way you can get it. Now, what the hell does function notation mean? Okay, what does this f brackets x bracket thing mean? Let me explain it to you. Give me a minute to erase this. Now, what this means is take a number, put it in there wherever you see x. Let's choose the number 2, okay? We're going to choose the number 2. Now, if I had to substitute number 2 in there, if I had to put in number 2 into this rule, remember the first rule I made, my personal rule. My personal rule was x plus 2. Now this rule says take a number, square it, and then times it by 2, and then add 1. That's what it's saying. Sorry, plus the 2x, which is times by 2. So you take a number, you first square it, all right, plus that number multiplied by 2 plus 1. That's the rule of this particular function. Okay? Now what does this mean? Again, back to this thing here is very important. That's why I keep stressing this thing here. I don't want to leave it yet because it's incredibly important when you progress. If you don't understand this, you're gonna struggle a lot with these functions, man. I'm telling you, this thing can be tricky. Okay? This means if like I said, if I had to take 2, if I had to use 2 as my x, what's going to happen is, for here, I'm going to put 2, square it, plus 2 times, whenever I'm seeing x, I'm putting a 2, plus that 1 over there. Now, I also need to put 2 here. What does this mean? This means the function rule, the f at 2 is going to be equal to that. Now let's calculate. 2 squared, what's 2 squared? That's 4 plus 2 times 2 is 4 plus 1. So 4 plus 4, that's 8 plus 9 plus 1, that's 9. The answer is 9. This means the rule f at the number 2 is equal to 9. If we had g, if you see something like this, g of 2 is equal to 3. That means the rule g at the number 2 will be equal to 3. Now let me make it make sense. I'll make it make sense to you. Now, this rule f, okay, it's called f. We can call it g if we wanted to. If we wanted to, we could call it g of x. If we wanted to, we could call it r of x. It doesn't really matter what you call it. Just don't call it x of x, okay? Because it's gonna look something like this now. Now this is confusing because that looks like x times the x, which is equal to x squared. Don't use this, okay? Don't use the same letter. Just understand it, okay? Just understand what we mean by this. It's a specific rule, okay? I can even change it. Let's say I use c of x because I'm calculating cost. Cost is equal to x squared, a number squared plus 1, okay? I can even change it. I can even use v of x for volume or p of x for perimeter, okay? It doesn't matter. What you need to remember is that whenever you see an x, you need to put the same number. Now, this rule C says take a number, square it, and add 1 to it. So let's take a number. Let's take, for example, what? 3. This is our x. This is our C of, You're going to understand this, okay? This column stands for our x, the numbers we input. This column stands for C of x. You're going to understand it, all right? So when we put in 3 here, this means take this 3, put it in there, and put it in there. So when 3 goes in there, 3 squared, that's 9. Plus 1, that's 10. So what does this mean? This means C of x, C at 3 is equal to 10. The rule C at the number 3 will give you the answer 10. Let's take another number, 5. We put 5 in there. 5 squared is 25, plus 1, 26. The rule C at 5 will give you the answer 26. Let's take another one, 10. 10 squared plus 1, 10 squared is 100, plus 1, 101. Again, C, the function, the rule C at the number 10 will give you the answer or the output 101. Same here. Let's use 2.5. Now, I don't know what 2.5 is squared, all right? But whatever, let me get a calculator quickly. What does that mean? It means the rule C, the rule, just like in the first lesson, lesson 1, when I spoke about that vending machine. The vending machine was the rule, because what does the vending machine do? Whenever I hit the button for Pepsi, it gives me a Pepsi. Whenever I hit the Coke button, it gives me a Coke button. That's the rule. That's all it does. So the rule C, or the only thing it does is take a number, square it, plus 1. That's all it does. So the rule C, we add the number 2.5 will give me the answer 7.25. So to write that out, C, which is the rule, at 2.5 will give me 7.25 as the answer. Now, similar concept, okay? But now we're reversing it. Remember when we were doing f of x is equal to, I don't know, 2x plus 1. Let me use this one, all right? What did you do in a couple of seconds back? We just took a number and we put it here and here. For example, the number 3. We said f at 3, the value of f, you can use GP, we talked about that, right? The value of f at 3 is going to be this x. I put 3 in there. We never see an x, plus 1. So 2 times 3 is 6, plus 1 is 7. So this means, if I had to write it shorter, same thing. I'm just choosing it to write it shorter, right? This means that the value of the function f rule, the rule function f, or the rule function g, v, p, b, whatever. But in this case, it's f. The value, whenever x is 3, this function, the answer will be 7. Now, what happens if you have something like this? Now they're telling you, let me write that properly. Now they're telling you that f of x is equal to 7. How is this different from this one? This one was the value of f at the number 3 was equal to 7. Now we have the value of f at x. X is not a number, but it's equal to 7. So what is this telling us? It's telling us that there's a specific number. Whenever you put it into that function f, we'll give you the answer 7. They're not telling us what that number is. They're calling it x, but they're telling us that there's a specific number, one specific number, that whenever you put into this function here, into this rule, will give you the answer 7. So if we had to write it out, what does it mean? It means that we must say 7 is equal I mean, that's what he said, right? We said f of x is equal to that. F of 3 is equal to 7. So now just replace the f of x with 7 because f of x is equal to 7. It's the same thing. They are equal. So just replace this f of x with this 7. And that's what we did here. So now we have 7 is equal to that. Now you just use your standard algebra, which I'm going to show you now. I don't want to rush it. I'm going to show you now, which uses standard algebra. So we're going to minus 1 from this side, minus 1 from this side. So 7 minus 1 is 6. 2x, nothing happens. 1 plus 1 minus 1, that's the same. Divide by 2. So this side divided by 2 is going to equals x. 6 divided by 2, that's 3. So x equals 3. Well, what does this mean? That means whenever f is 3, whenever f is at 3, the answer will be equal to 7. Now let's test it out. Now I erased it now, but a couple of seconds ago I wrote for you what f of x was equal to. F of x was equal to 2x plus 1. I think that's what I wrote. All right, now let's test it. Let's put 3 in there. So we're putting 3. This, by the way, also shows what number we're putting in there. Okay, if you have something like this, if you have something like this, if I just showed you this 3 tells you that the number you substituted into here was 3. That's how you got 7. This number tells you the number you had to put into that equation to get 7. Think about it. If this number was in here, if you said something like f is equal to 7, yes, the rule f is equal to 7, but what number did you use to get to 7? You see? So that's why you need to write it like this. Well, if you wrote it like this, you breaking the function notation. Don't write it like this. I'm just giving an example of why you have to write it like this. Because this makes sense. Take 3, put it into the rule, and you will get 7. Whereas if you gave me this, I'll say, okay, f is a rule, 7 is the answer, but what did you put in there to get 7? Very confusing. Now let's test if the 3 we got here is true. 2 times 3, that's 6 plus 1, it's 7. So it's true. F of 3 is 7. Or f at the value 3 is 7. True. Evaluating functions. Now, here's one more that I want to go with you through, okay? One more. Now this one is not a number. We're not using numbers. This one, I think this one is the final blow, all right? So hopefully it's the final blow in a good way. I'm going to give you a simple one. Let's use G now. Let's use G. G of x is equal to 2. Now let's use 3. 3x plus 2. That's our function. That's our rule G, okay? Now, I tell you, don't substitute a number. Substitute x plus h. What? X plus h. I tell you, no, don't substitute 3 like we did a couple of seconds back. Don't substitute 2, not a number. X plus h. What do? You do the exact same thing. Remember what you did. Now forget this x plus h. Let's say we're using substituting 1. Remember what you did. We took out the x. We removed the x. We put the number we're substituting. Number 1. Again here, 3. You remove the x. You put the thing you're using. Plus 2. And this answer will be 5. So what do you do here? You take out that variable. You take out that x. You put in what you're substituting. You take out that x, you put in what you're substituting. If we were using 4, we take out the x, we put in 4 in its place. We take out the x, we put in 4 in its place. So we're going to do the exact same thing, okay? It doesn't matter if it's letters. We don't care if it's letters. So what is going to be? It's going to be g x plus h, because that's what we're substituting here. Just, we took out the x and we put x plus h. Take out the x, put the x plus h. If you don't want it to be confusing, let me change it. Let me change that x into an a. If I tell you to substitute that, a plus h. Take out the x, like we did in the previous examples. Put there, a plus h is equal to, again, whenever you see an x, you put the same thing, a plus h plus 2. Now, algebra, we're going to use the FOIL method, all right? We're going to use the FOIL method to expand that, algebra, all right? So this 3 times that a is going to be 3a. 3 times that h plus 3h plus 2, that's our final answer. You cannot add them, right? They're not like terms. That's our final answer. That's an answer, see? Yes, that's an answer. That's an answer. It doesn't look like an answer, but that's an answer. Because the value of g at a plus h will give us the answer 3a plus 3h plus 2. It doesn't make sense when you look at them, but that's the answer.